XYZ. Today I'll be taking you in pipelining and parallelism computing. First we're going to define pipelining and parallelism computing. Then we're going to do pipelining concepts and the types of parallelism and their benefits. What is a pipeline in a parallel computing? A pipeline is also known as a data pipeline. It is a data processing element connection in series, where the output of one element is the input of the next one. The elements of pipelining are often executed in parallel or in time-sliced fashion. Pipelining. Pipelining is the process of accumulating instructions from the processor through a pipeline. It allows and executing instructions in an ordinary process. It's also known as pipelining processing. The pipeline is a technique where multiple instructions are overlapped during execution. Pipeline is divided into stages. These stages are connected with one another to form a pipeline-like structure. Instructions enter from one end and exit from another end. Pipelining concept. Dividing instructions into stages. Pipelining involves dividing the execution of an instruction into several sequential stages, such as fetching, decoding, execution, and writing back the result. Concurrent processing. Each stage can work on a different instruction simultaneously, creating a parallel process effect. Increasing throughput. By overlapping the execution of multiple instructions, pipelining significantly increases the number of instructions that can be processed per unit of time. Then the benefits are analog to an assembly line. Think of an assembly line where different workers perform different tasks on different cars simultaneously. Similarly, in a pipeline processor, different stages work on different instructions. Then we have types of parallelism. We're going to talk about binary parallelism, instructional level parallelism, and task parallelism. First, binary parallelism. It refers to perform multiple operations simultaneously by processing data in bits or binary digits. The binary digits are ones and zeros, in parallel rather than sequential. This type of parallelism focuses on processing multiple bits of data concurrently, often achieved by increasing processor weight size. The number of bits can process at once. Binary parallelism is crucial for improving the performance and efficiency of computer systems, allowing them to handle complex tasks faster. Then we're moving on to instructional level parallelism. It refers to the technique of executing multiple instructions simultaneously within a CPU core by overlapping their execution phase, enhancing performance without requiring changes to the code. Then pipelining. A fundamental IOP technique involves breaking down execution of instructions into multiple stages. These stages are fetch, decode, execute, and write back, and overlapping these stages for different instructions. Out to order execution. Modern processors can execute instructions out of the original order as long as the program logic is not affected, to further enhance parallelism. Then there is multiple execution units. CPUs with multiple execution units can execute different instructions simultaneously throughput. Then we have instruction ordering. Compilers and processors can reorder instructions to improve parallelism by identifying independent instructions that can be executed. Then the benefit of instruction level parallelisms increase performance by overlapping and executing instructions in parallel. ILP can significantly improve the speed and efficiency of a processor. Then we're moving on to task parallelism. It involves breaking down a complex task in order to then we're moving on to task parallelism. It involves breaking down a complex task into smaller independent subtasks that can be executed concurrently by multiple processes to improve performance and speed execution. Then there's a large task which is divided into smaller independent subtasks, and each subtask is assigned to a different processor or core for simultaneous execution. This allows multiple parts to tasks to be processed at the same time, leading to faster overall completion. And then the benefit is it allows better utilization of available computing resources such as CPU cores and GPUs. And thank you for watching this video. Hope you will subscribe. Meet you next time.